All right, hey everybody, I'm Storm Team 2 Chief Meteorologist Rob Fowler, and what I really enjoy most about my job is going into the schools and talking about weather. But obviously, with what's happening here in our world today, schools are no longer an option, at least for a while. We hope, keep our fingers crossed, we'll be back in before this year is done. So I thought I would kind of give all of you a taste of our presentation that we take into the schools. And kids, some of you, I've been to your school, you've probably already seen this. For parents, this is what we talk about when we go into the schools. Now, here at Channel 2, we call our storm team, our weather team, Storm Team 2, and we have 3 meteorologists currently on staff, myself, Josh Marthers, and also David Dixon. Now, our building is in Mount Pleasant, but we're really responsible for forecasting the weather almost all the way to Myrtle Beach, almost to Orangeburg, and almost down to Beaufort, so really most of eastern South Carolina. Now, this picture right here, that's our weather office, and what I tell the kids is that's like our classroom. That's where we go every day, and that's where we learn about the weather, research about the weather. Then, after we've learned what we need to know, we go downstairs. So these pictures are probably a little more familiar to you because that's our studio. That's where we actually present the weather, the news, and the sports each and every day. Now, I'm not sure if you know this, but every single night when we do the weather, we stand in front of a wall that's painted green. Folks, there is no weather map behind us in person. There is on television, but in person, all we see is a green screen. And what you don't see at home on your television is a television set to my left and a TV set to my right. So when I turn it, it looks like I'm looking at a weather map. What I'm really looking at is that television set over to the side. If I had no television, I would have no idea what I was pointing to because, as you can see, all I've got behind me is a green screen. Now, you don't get to see the green screen at home. You get to see me, in this case, standing in front of our extended forecast. Now, a lot of people say, how does this work? Well, I kind of think it's magic because the cameras that we use are very smart. We've told the cameras that anything they see the color green to replace with something else. So the camera is looking at the green wall and putting our weather graphics in place of the green. But that brings up a really interesting question. I have a white shirt on today, but let's say that I go home and change into a green shirt. If the camera's looking for the color green and replacing green with the map, if I have green on, what's going to happen? Well, if you said you would become the map, you're absolutely correct. In fact, I've got a slide. We'll kind of do a little experiment. I'm holding a green piece of poster board, kind of simulating a green shirt. Now, if you were in the studio that day watching in person, you would see me holding that green piece of poster board. But chances are you're at home watching on television, so guess what you would get to see? That's what you would get to see. So wherever the green goes, that's where the map goes. So obviously, I can't wear a green shirt, can't wear green pants. I might get away with green socks and green shoes. I also cannot wear a green tie. So green is kind of a no-no color. Well, let's talk about our relationship with the Charleston NWS. That's the National Weather Service, and they're a government agency, and their job is to collect weather data, like what's the temperature right now, what the winds are doing, how much rain we've seen. It's our job then to get that information out to you in person on television. And you might recognize the FAA tower. They're located adjacent to the Charleston International Airport. Well, some of the tools that we use, one of the tools is weather satellite. Very, very important. A weather satellite is built by some very smart people, and they put a special kind of a camera, sensor inside. And that sensor, that camera, is looking down on the planet Earth and taking pictures. And when it takes pictures of the clouds for us. Now, a lot of people say, how did you get that satellite to space? Well, we put it in a rocket that looks like that, went up to 22,000 miles above the Earth, dropped it off, left it there, and it started taking pictures. And a satellite picture would look something like this. And you're probably familiar with seeing pictures like this on Channel 2. But on this particular day, there were no clouds over South Carolina. But there was a big storm over the middle portion of the country from Nebraska through Kansas, Oklahoma, and Texas. So when you watch us on television, we usually don't just show a static picture like this. We show what we call a loop, where we put picture after picture together. All the satellite pictures we have taken, we put them together, so now you can see how the clouds are moving, and that helps us when we're forecasting the weather. Now, our satellites, we got you covered. We can see North America, South America, the continent of Africa. We can go over to the other side as well, over the Pacific Ocean, all the way out to Hawaii. So, again, we can see all over the world with our satellites, so we kind of know what's coming, which really comes in handy for us during hurricane season from June 1st to November 30th. This is a picture of Hurricane Francis back in 2004, but a lot of you remember this picture. This was Hurricane Hugo in 1989, and as you can see, it was a big hurricane, roughly 600 miles in diameter, and the average hurricane is about 300 miles, about half that size. So having the satellite, now we don't always know which way the storms are moving, but we know they're out there, we know what they look like, we know how big, and the way we know that is by using our satellites. Another tool that we use, tool number 2, is what we call weather radar. Radar is an acronym for radio detection and ranging. And the radar is on a big tall metal tower. There's a giant white ball on top. We call that a radome. And inside the radome is a special kind of antenna. And that antenna is constantly going around sending out signals through the air. And sometimes those signals bounce off precipitation and then come back to the radar site. We also have to be careful because sometimes our radar beam can bounce off other things like migrating birds. It doesn't hurt the birds, but what it does is it kind of messes up our radar. But generally, we're looking at a radar picture looking something like that. So all of those colors indicate where the radar beam went out, bounced off precipitation, and came back to the site. And on this particular day we took the picture, all those white dots signify lightning strikes. So if you ever wondered, how does that meteorologist know it's going to storm this afternoon? That's how we know. Now we're of course really excited to have a special feature, special radar called the Doppler radar, which can look inside the storm, detect whether you've got incoming air, incoming winds, outgoing winds. When you put those two together, then that can create circulation up in the storm that would be a precursor potentially of a tornado forming up in the clouds before it comes down to the ground. Of course, officially not designated a tornado until it hits the ground, but still that gives us some warning that we really couldn't give you before. Our third tool is what we call the weather balloon, and you can see that's the weather balloon. Every single day, 2 times a day, from Charleston and roughly about 100 other cities around the country, they launch weather balloons at the same time, and those balloons are filled up with helium or sometimes hydrogen, and they start out basically about 6 feet wide and can get to about 20 feet wide before they burst up in the atmosphere. Now, we don't have enough lung power to do that, but we use a tank of helium behind this gentleman, this meteorologist, and he's filling it up. And once it's filled up, the meteorologist will take it outside and they'll be ready to launch it. And attached to it is this white box. This is what we call a radiosonde. And I just so happen to have one of the newer radiosondes right here, and that basically goes up with a parachute. And as the balloon goes up, it generally goes up roughly about 20 miles high in the sky. And as it goes up, it is giving us very vital weather information that we so desperately need. So there it is. That's called the radiosonde. That was this box right here. We also have a parachute, and there's the weather balloon. And again, generally can go up to about 20 miles high. It's usually 1 or 2 hour journey time, and maybe 75, 100, maybe up to 200 miles away, generally closer to 100 miles from where it's launched, is where the balloon will burst, and then the radiosonde will come back down to the ground. We only get about 20% back, but let's say that you did find a weather balloon that fell in your backyard. It usually comes with a bag attached to it that has a mailing label. You can put it back in, send it back to the National Weather Service, and if they can fix it, they can use it again. In fact, I just so happen to have, this was one that a gentleman from Wadmalaw Island dropped by a few years ago, and this fell in his backyard, and this was the radiosonde. There's the burst balloon, and this was the parachute that came down with it. When the basically the balloon pops, the radiosonde will come back down, and the parachute will slow it down about 22 miles an hour or so. We don't want anybody to get hurt by that. So where does this information go? Well, it goes into a room that looks like this, filled with meteorologists and all kinds of computers, and then the computer models we talk about a lot. They will put together a map for us, and all these colors, all these lines, all these numbers on the computer model map are something for us to interpret and read, and that helps us forecast the weather. So that's kind of some of the tools that we use, some of the things that we use to help us put the forecast together. And we mentioned the weather balloon. Here's, again, a weather balloon that's not popped, and I get to show this to all the kids. And you can see it's made up of latex, so it's kind of a rubbery substance. And then here is the radiosonde again that we use, and inside is the parachute, the handy-dandy parachute that we use as well. Now, here's the last thing I want to show you guys, and this is what we call a handheld weather station, but it has a thermometer on it that measures air temperature. It also has an anemometer, which is the instrument to measure wind speed. So when I take this to schools with the kids, we have a lot of fun with the anemometer, and we pick some kids and they get to blow into the anemometer just like that. And that was a gust of about 11.3 miles per hour. So this is a great tool to have also to tell you the temperature as well as what the winds are doing. So hope you enjoyed our little Weather 101 here, and certainly if you have any comments, any questions, leave them and we'll try to answer them. But I know it's a tough time for all. We encourage everybody to stay safe, wash those hands, social distancing, as we've come to learn that term a lot here lately. But I can't wait to get back into the schools, and I can't wait to see all the kids again. And teachers, thank you guys for what you're doing at home, online, making sure your kids continue their education. And again, I look forward to being back in the multi-purpose room or the cafeteria or the classrooms of Low Country schools to tell you about weather. I'm Storm Team 2 Chief Meteorologist Rob Fowler. You guys make it a great day.